Okay, so the next talk, Clemens was actually talking to us last year at MindSwap about M, and he's back for an update
Back.
and what's happened since then.
Well, you can't hear me. Can you hear me? Yeah, thank you very much. How's that? Okay. All right. So, in fact, this is the fourth time at the MindSwap that I'm talking about M. So I'm kind of insistent. What I'm trying to talk about today, and I'm saying trying because you'll see, is how M, now that it has shipped twice in the Power Query product, is beginning to sort of go to other places that may or may not be good for it. But I just want to spread the meme that M is slowly going elsewhere. So you could argue the letter M is on fire right now. So the thing that we observed that led to M in the first place, and the thing that I've been talking about a few times in the past several iterations, really was all around why the heck did we even do yet another language? And we certainly thought about this very long, very hard before embarking on it, and again, at many juncture points, we thought, oh, maybe we should just shut it down. The ultimate motivation, and it's not unique to Power Query or M, of course, is this old observation that about 100 years ago, a little more than 100 years ago, if you wanted to drive a car and you weren't an extremely adventurous character, you would actually want to have a chauffeur. And the main reason was, even the name chauffeur points at that, that the guy had to, for example, go and know how to preheat the engine by hand until it would actually be a self-sustaining internal combustion engine. So if you would just fire it up, it would immediately die again. There was none of the very sophisticated regulation mechanisms that we have today. Then the tires would routinely get punctured, so on any decent ride, you would have to expect to swap out or patch of tires, and so on. So you basically had a thing that required a person to sort of allow you to go from A to B. And one of the consequences was that Daimler, that's the Daimler from Mercedes-Benz, said there would never be sort of a market for more than about 1 million cars worldwide, simply because there aren't enough drivers around. Okay, so we know that we got beyond that point, and it's clearly because most of us end up driving ourselves, right? And so related observation from the 77, exactly the same time when Bill and Paul Allen at the time came up with a computer on every desk and in every home, exactly in the same year, Ken Olsen claimed that there was a very, very limited number of computers that you would ever have in the world, in particular that you would never want to have a computer in anyone's home. And much of that was inspired by the idea that, if you want to run a real computer, you'll have a sysadmin around, and if it has to have a database on it, then you'll have a DB admin around, and so on. And you don't want to have all these people in every home. Right? Okay. So we know the world actually moved beyond that point too. And so then we ask ourselves, so what is a programmer, the way we usually define it, right? And so if you think about that, you're saying, okay, great. In many ways, programmers are the chauffeurs of our computers, right? They don't actually build the computer. So they're not really the engineers who build the computer. They don't normally program the operating system, right? They don't really make the car, so to speak, but they add, for most of them, they add the application that makes a company, for example, be happy to have those computers in the first place, right? So in that sense, they're the chauffeurs of your computers. And the immediate question, of course, is, and it's not really thought-provoking because this has been around as a meme for a long time, but there's this notion of end-user programming, just like I can drive my own car. I want to program whatever I need to do myself so that I can solve my daily problems. Right? And it's important to not get confused there and say everybody should work on their own kernel or something. So when you want to do that, the immediate question is, what's an appropriate language for a very large audience to actually get going? And so there's a number of reasons that not all languages are created equal for those purposes. And here are a few kind of dimensions that I like. For example, I like this notion of read-only and write-only languages. SQL is a good example. Pretty much everybody I meet, not just in this company, finds that they can make sense of reasonably compact. I mean, you can have pages and pages of SQL, of course, but reasonably compact SQL expressions, most people can say, oh yeah, I think I know what that does. And they're usually pretty close. They may not have fully understood the last little sort of tweaking hints that you can give, but fundamentally they got it. If you ask the same people to write anything in SQL, most people throw up their hands, or they try and fail unless they get machine support. Turns out SQL is a pretty good example of a read-only language. Then there are, of course, all sorts of write-only languages, like Perl, for example. And of course, if there's any Perl enthusiasts in the audience, I apologize. But my experience is these languages are really great at writing something right then when you need it. And even you who wrote it will have no idea anymore what any of that meant, maybe the next day already. Okay, so that's kind of the concept of write-only. Then there's, of course, an area of both impedance and requirements mismatch. Impedance mismatch is if what I wanted to write should have fit in a line, but I have to write 100 lines just to make it work, then that's a mismatch. Likewise, if I write something that works just fine, but is a million times slower than what I need, or has created a huge security gap for me, or has exposed myself to identity theft or something, then there's a big requirements mismatch. Okay. So this is the old thing. And of course, this, by the way, the stack wasn't specifically crafted for you. So many of those things, I hope, are a little bit kind of messages to the choir. But if a lot of people think about the one language that they like the best, and every other language, therefore, isn't what they want to look at. And so there's this law of the instrument that when I looked it up, shockingly goes back to 1966. I always thought this is a more recent thing. This phenomenon that if you only have a hammer, everything looks like a nail. So if you only have the one language, then everything looks like a problem that can and should be solved with that language. Okay, so another way of looking at things is you can go and say, I can try and get my language to track closely to what specific machines are good at. Right? And you could argue that the world of the universal computer is over. We're just going from multi-core, NUMA, spectrum from tiny battery-operated device to full cloud data center. Right? It's like there isn't the one computer model to rule them all anymore. And so the illusion that you can ignore that end of the scale has gone away. And then at the other end, the kind of things that people want to do keep exploding, keep getting more aggressive, more interesting. So basically, you can say, hey, I go with a language that is closer to the machine models or closer to the domain models. And if I try to attract the biggest audience, I might actually do this simple, not quite mathematical thing in the middle and invent a general purpose language. Right? And it turns out there are some reasons why these general purpose languages have their own issues. So we already talked about that. So one thing that with the Power Query kind of work that we pushed for is this really old query by example, programming by example thing. Query by example also goes back to the mid-70s. Looks like all good things I'm referring to today started in the mid-70s. And some people of you would agree. And so programming by example really is saying instead of writing the code to go from A to B, you start with A and you basically manipulate what you're looking at, manipulate the data, the state, or something in steps that the system can watch, and we basically build a program to basically repeat that every time you want to do it again, right? So the recording mode in good old macro systems, in Office, for example, is a very clumsy form of programming by example. Okay, so the reason I'm mentioning this is that the idea of teaching a system by going through examples is much more effective for many people than to actually go abstractly and solve the problem by writing down an entire algorithm, entire program. Okay. But again, not all languages are actually kind of good at that. So to now finally break the math here, so if you add this notion of complexity, languages that try to go for the thing in the middle get super complex, and therefore I claim that in terms of reachable audience, they actually hit a dip. So I'm looking at my C# friends, for example. C# keeps getting more interesting every year. I love it personally. I do wonder what part of the world audience will still master all of C# as an example. And C# is probably the best done language in that space. All right, so here's what happens when anyone can drive a car. The downside, of course, is everybody will drive their car. And or to speak with Sam O'Cray, if everybody is a programmer and everybody who is a programmer does something. By the way, this image is Photoshopped, but it's not very far away from reality anymore, right? It's like if you look at I-5 going through Los Angeles, for example, now being a double-decker 16-lane monster or something. It's actually pretty close to that. Right, so that's the problem, right? If everybody can drive a car, this stuff happens. If everybody can write their own programs, this stuff happens. Everybody will write their own programs, and unexpected things will happen. But you know, that's the fun part of it. So quick question, who has used Power Query in here? Just a few hands up. Should all be ashamed of yourself. So those who didn't. I'm very proud of everyone who raised their hand. So Power BI, that's the larger offering that shipped in early February, has been deployed by MSIT for everybody at Microsoft. So you can just get the Power Query add-in, and then let me see whether you can see this up here. Can't really see it here because I only show you the editor. In Power Query, you can log in, and then you can go and happily share, search for views. Little programs you write in Power Query are really just views over arbitrary data, and you can share those, you can find those, you can curate those. So I encourage you to all play with that, because in many ways there's a little language behind all this, and that's the language I keep talking about that we affectionately call M, and this is currently the best embodiment of M. So I'd encourage you to play with that thing. But since I talked about Power Query last time, it was already a full year ago, and in the meantime it shipped. Last summer we shipped the standalone version of this thing, and as I said in February, we shipped the larger Power BI offering, and now we actually also know how to make money with this, because Power BI is a for-subscription service on top of Office 365. And we're actually seeing quite interesting kind of adoption growth right now. Okay, so the target audience, the guys who should drive their own cars, are the users of things like Excel, in particular of Excel, but not just all Excel users. We're not quite that ambitious yet. So it's a little bit like cars before built-in navigation systems. Right? So we are basically saying we target the top 10% of Excel users that have recognized that there's a formula bar. The other 90%, I don't know what they do. They edit lists in Excel or something. And maybe it's 20%, but it's like it's a part of them. The important thing is that we found that that in terms of language constraints, we had to design a language that is all different from what we would have designed for anyone in this room. Biggest point, limited syntax. We didn't go quite as far as Excel. Excel makes everything look like a function, even if it isn't. We didn't do that, but otherwise it's mostly that. Almost everything is a function, and the big thing that differentiates what we did from what Excel has built in and what, for example, the DAX language in Power Pivot does is that we are targeting a very wide range of data models. And I'll show you something quite different from what I've shown before today. Okay, so this one is just a side-by-side comparison, and it doesn't want to go to the next one. That's strange. You've probably seen that before. That's just showing how a language with close to no syntax, M, ends up doing something like a join that in T-SQL has quite a bit of syntax to it, in C# has quite a bit of syntax if you use the link built-in kind of syntax, the query comprehension syntax, and otherwise M looks very similar to C# when you're just using the link pattern, except that the style we unroll things by doing linear let chains ends up more readable to the kind of people we are targeting. But it's really the same thing. Right? One thing to note is we have no concept of objects or virtual dispatch or any of this. Okay. So the language is dramatically simpler than even the expression subset of C#. Okay, so it turns out M is a dynamic language, much like JavaScript. It tends to run until it hits a hard failure instead of telling you early that in some corner case it might not be able to run. It is essentially a functional language. The biggest exception is that all external data is stream processed to avoid unnecessary buffering, and therefore you're exposing yourself to external state. If you keep processing the same external set repeatedly, then depending on whether it ended up fitting into some caches, you may or may not see non-determinism. The biggest decision was to actually go with higher order functions instead of control flow. So there's absolutely no control flow in the language. If is in the language and recursion is. So all of you familiar with Mr. Turing know that that's enough for control flow. We do nothing to stop you from stack overflowing, and we make if sufficiently clumsy that if you want to write a switch using lots of chained ifs or something, it looks so horrible that hopefully you don't do that. The only reason if is in there is that it is a non-strict construct, the only non-strict construct. So the other thing we did is, since the notion of higher order functions in very many cases leads to little single argument anonymous lambdas being passed around, is we allow one little bit of syntactic sugar in M, where instead of writing things like this, that looks very much like a C# lambda here, you can do this. So you can actually, this down here is still equivalent to what we had initially, and this little each is effectively saying introduce a unary lambda where the parameter has the name underscore. Okay, and that's really all. The other thing is that field access, which in M is done with square brackets. If field access syntax is used without a variable name given, then it defaults to underscore. Okay. So this is how we eliminate anonymous lambdas in very many use cases from our users' site. Right. That's the only piece of syntactic sugar that we have in M. All right, so this is a little bit more detail around how evaluation actually happens. I mentioned the if thing. So in Excel, if is a function that you cannot explain unless you want to go all the way to call by name or something. So it looks like a function, but it's non-strict, while all other functions are strict. In M, there's actually an if. More interesting is actually this point here. although M is as such an eager language, the construction of complex types is lazy. And that, of course, allows all the tricks that you know from LINQ, where we just can gather up expression trees over things without doing any work until you finally really force us to do work, and then we can do something smart rather than having done tons and tons of big intermediate calculations. Okay. And we can therefore, because we are kind of lazy at that level, we can deal with more crazy things like infinite lists or infinitely deep trees, or also interesting data structures that are actually partially broken. It's very common in practice, unfortunately, that you pull data in from some external source, maybe some text file, and some of the columns happen to be broken. So really all you want to do is still be able to work with it, then throw the columns away that you don't like or cleanse them, and then keep working. Right? Anything that would force you to die early because that column had type mismatch errors in it, although you couldn't care less about that entire column, would basically stop people from doing what they need to do. All right. By the way, if you have any questions, please just throw them at me. Not literally, though. Okay, so then when we start thinking about where else M could go, here's, let me just go back. Yeah, so here's an example in our current Power BI offering. People go and upload Excel workbooks to SharePoint Online. SharePoint Online now has a feature to schedule refresh. And since if you use Power Query to get your data, refresh really means going back to data sources that are likely on your premises. What we actually end up doing is we run the runtime for M in a server product called Data Management Gateway that is linked to our cloud offering. And so then companies that want to deploy that gateway can enable cloud refresh of workbooks over on-premise data. And so that's not a very fast stretch of using M. The only thing that happened here is that the runtime of M traveled to another product. But it's still the same M, and the authoring environment is the same. You're still using Power Query to author and so on. So this one is not a very fast stretch. Another one that keeps popping up, and we haven't really put any significant dollars on that, but people keep saying, hey, I have this little declarative configuration thingy, and in the middle of it, I keep needing sort of little expressions. It's a little bit like if you have XML, you invent XPath the next day because you want to embed little expressions everywhere. And so people are wondering, what could that language be that is simple enough, controllable enough, resource containable enough, secure enough, and so on, that could actually just be the definition for these mini expression languages that want to live in all sorts of places. And so we have one current sort of example of that in, do you see that here anywhere? Maybe here. In the modern data pipeline system, that's an orchestration system that we're currently building. They had that need, and so they didn't use any of our bits. They just literally took the M language definition for certain expressions and just copied it. But this is an opportunity that might show up. A more interesting one that is currently being sort of deeply explored is data ingress. So you're saying, okay, you can use Power Query to break open text files. You can break open binaries. So that's something I'm going to show you today. And you can go and make sense of textual or binary formats and transfer data into better shape in Power Query. So doesn't that sound like something you would want to do if, for example, in big data production systems? Right? In Hadoop, for example, you have these deserializers. In Cosmos, you have extractors. These are usually handwritten pieces of code that know how to translate, I don't know, pick one of your favorite formats, Avro, whatever you like, Ray, Bond, so on, Protobuf. They crack these formats and translate them into some data structure that then allows you to put further processing stages on top. Turns out you can do this stuff in M. Has nothing to do with Power Query as such. And you can use the M runtime in those places to have a generic extractor. And that's something we are looking at right now because it would allow a lot of people to get a working extractor quickly, and they can then defer the investment in handwritten ones and only do that if they, for example, find they really have the sort of additional performance need. So here's an example. We have, so this is a way of defining a binary constant, a constant in M itself. So just a list. That's list syntax in M. So for those of you who are familiar with JavaScript, just flip your mind upside down and think list whenever you see curly braces, and think record or object whenever you see square brackets. So it's exactly the opposite, but more in line with what Excel does and what math notation does too. So you have a list of bytes. So this could, of course, have been the content of some file stream or something, right? And here's a little bit of M, where the entire trick here is the collection of functions in our library that are all in this binary format group. And so, for example, what we are saying here is the format of a point is a record that consists of 2 signed integers. And you see here's a point. Here's 1 signed integer. Here's another signed integer. So 3 and 4 would be the coordinates of 1 point, 5 and 6 coordinates of another point. Then around in the file format, we are saying file format is based on an unsigned integer. That's a value that gets passed with that format. Pass that value that once passed into the second argument, which is a little lambda. Here we could have used each. So we now claim that what we just write is a count, and we create a list using the point format of count elements. And finally, we're saying, okay, now that we have these, that's really the syntactic definition of our file format. And now we're saying, please apply that file format to the actual file contents. And remember, thanks to the laziness of construction, although we have now basically created a gigantic expression nest, well, a tiny expression nest in this case, we haven't actually done any work yet. So it's really only when you do this application down here that we're saying, okay, given this expression nest, correct this binary format, and at this point we have the opportunity to do something smart, like, for example, create a state machine or something. And the result of running this is just what we see down here. And in fact, since no one ever wants to believe PowerPoint, let's just, for the fun of it, do this in. So I'm just taking whatever I have here in my PowerPoint, copy, go to Power Query, and say blank query, which is basically saying type in any program you like. Okay. So what we got back is a list with 2 records. Open this navigator here, and if you look at the records, we'll find the first one has 3 and 4 as its points, and the second one has 5 and 6 as its points. So there was no other stuff required. Just go back to this one here. Okay. All right, so we just had this little piece of M, and really what just happened is we took the syntax of some file format, and of course this is trivial syntax, and almost literally copied the syntax into M expressions. And so you can actually see how a lot of people can learn to do this, especially since you can do copy-paste of nested formats that appear elsewhere. And then what you get back when you do that is a function that, when applied to the actual binary data, will give you the correct data. And that's it, right? So there's almost no user-level visible magic here. There's quite a bit of magic in the implementation, of course, to make this work and make it work reasonably fast. So The most interesting example, function here in this example is this binary format choice function. So it actually, if you really want to understand what it does quite a bit of stuff. It actually goes and reads the first argument, then you can see it on here. So it reads one value, then assumes that the second argument is a function, passes that in. The choice function itself inspects that value and returns a second binary format. The second binary format is used to read the second value. The second value is returned. So you would want to understand that at that level of detail if you try to really, really by hand construct these things and know what you're doing. Turns out most users will happily pick up an example and tweak it a little bit and make it work without reading. This is literally taken from our spec, but this is the kind of stuff that most people that we are targeting won't read. So the actual binary format library has a number of functions in it today. It knows how to crack these kind of little atoms at bit level. And of course, we can add more. It has functions to read particular sets of formats. Byte order is just a way of dictating whether it's kind of, how do you call these things? Big endian, little endian, thank you. Just escaped me. And then you can just talk in terms of the output types really in M. You can say, I want to get a binary blob out, I want a text out, I want a list of values, a record of values. With length, you can virtually limit the stream. So most things read streams to the limit. And if you put length around something, you can have a substream inside a format that is limited by a length that you picked out somewhere else. That's a fairly common thing in binary formats, that they have length-limited substreams. Choice we already looked at. Group and transform, some tricks to sort of deal with interesting sort of groupings in your actual formats. And so what we have done is we have used that to crack a number of big data formats. But we've also used this to, for example, get the metadata out of the header of a JPEG file. And you can imagine how useful that is if you have a huge library of media files and you want to do some data crunching over the metadata in those files. Right? And again, you just pick up the M definition for one of those binary formats and you start using it like a function. All right, so then the other interesting thing is when you look at how Power Query deals with M, the Power Query runtime, the mashup runtime for M, tries to not do any work. So what it does is it tries very hard to wait until you really want the data, then pick up these expression trees and do what Entity Framework, Link to SQL, all these guys do, except that it supports any number of parallel data sources, and then sends queries to the source wherever that is possible. Right. Now, in the case where the target that you're folding M2 is something like the scope language in Cosmos, or it could be the Hive language over Hadoop, where there is a nested world of cracking binaries. You can actually see how you can end up with a solution that does effectively double folding. So you write your M where you're saying, hey, this is my binary format cracking stuff. This is my larger work of mashing up data over the cracked data. The folding pipeline would just generate a scope query from this entire thing where the data extracting stuff ends up being still M that is passed to a generic extractor as a parameter. Right? And then at runtime, the scope system invokes the extractor. Normally that's handwritten C# code in scope, but here it is just written once and it takes M, uses the M runtime to then do the actual binary extraction. So you actually get a single flat M story on the outset of the system. You get the full kind of big data scale out from scope, and you still get the very flexible access to the binary data on the inside. So that's probably one of the farthest points we are currently sort of pushing M. Okay, and of course the future is this. We don't want to have any drivers anymore. That's where we're waiting for. We're starting to work with guys in research on effectively automatic programming, not just programming by example. That's all the flash things. Okay. And so this picture here predates the mid-70s, as you can see. And the only reason you can tell that this is not real is that A, these people actually play a board game while driving. They should all be browsing Google web sites, right? And B, the freeway, despite having only 3 lanes, is actually essentially empty. That's even less likely if the cars are driving themselves, right? Oh, no seat belts. Very good, very good. You don't need seat belts if you don't have imperfect drivers. I made that up, I don't know. So the law would probably require seat belts and helmets. All right, so in terms of supported data sources, just a little flashback. You have seen this list before in all likelihood. We have added more interesting things recently, like Exchange. So if you go and pick up Power Query today, then you can connect to your own Exchange mail account and get all sorts of interesting stats. You can, for example, ask yourself, how long does it take me to read an email? Or how many of my emails do I never read? And the other thing that we just sent into public preview today is a backend to SAP Business Objects. So with a little bit of luck, MSIT still has to deploy that for us. And you have to have access rights, of course, but that should enable another huge playpen of interesting data. Okay, what else? Okay, I already mentioned that. That's all that I had for today. And we are like 2 minutes early, which is very unusual. Yes? Right. Yes, yes. Yes, so it's very interesting. We worked with that team during a much earlier phase of the M effort, while there was still a project called Oslo, and we were more focusing on modeling. And then it diverged again. So yeah, we should probably go and touch base again, especially now that we actually have all these binary things in the shipping product. Yeah, building a protocol analyzer that basically on the fly looks at what's exchanged and making sure that the end-to-end protocol is not violated on top of this could be interesting. There might be performance issues, right? Depending on if you need to do all this at wire speed in a sustained way, you may need slow wires. But yeah, definitely interesting. I mean, they generate state machines to do this, so we would have to do the same thing here. Okay. They might even benefit. Interesting. Yeah, if you have any current pointers, that would be good. Has been a few years. You guys are all awfully quiet. Is it just post lunch or?
Seriously, post lunch. Thank you, Clemens, for once again coming and informing us.
Absolutely. Yeah. You're welcome.